Alright, this is chapter 1-4, Algebra 2, solving equations. So, an equation is an expression, two expressions that are equal to each other. So, I have this expression 2x, I have this other expression 10. This expression and this expression 2x and 10 are have an equal sign in between. Since it has the equal sign, then we can say that this whole thing is an equation. And there's certain rules to equations called properties that apply across the board. So remember, properties are rules that are always true. There's not a situation where you are given a property and it's false. So the first property that the book talks of is that of the reflexive property. Oops. And the reflexive property says that if I have some letter A, it's always going to be equal to itself. A is equal to A. So if I have the number 5, well then the number 5 will be equal to the number 5. It's like looking into a mirror. Reflexive property. Then we have the symmetric property. And the symmetric property, actually that's more like looking into a mirror, to be honest with you. The symmetric property says this. The symmetric property says that if A equals B, then B equals A. If A equals B, then B equals A. So if I have, the book uses 1/2. So if 1/2 is equal to 0.5, then I can say that 0.5 is equal to 1/2. They're interchangeable. So the 1/2 can be either on the left-hand side or the right-hand side of the equal sign. The 0.5 can be either on the right-hand side or the left-hand side of the equal sign. I can switch them, and the equation sign will remain true. So I'm going to say that a lot. Equation sign will remain true, meaning that both sides are equal to each other. Another property is the transitive property. And these are all properties of equality. You will see as we get into this book, we also have properties of congruency. And that will deal with the congruent symbol. Transitive property of equality says if A is equal to B and B is equal to C, then A is equal to C. Transitive property of equality. And what the book has is 2.5 is equal to 2.5. So this would be my A, and this would be my B. And 2.5 is equal to 5/2. So this is my B, and this is my C, right? So A is equal to B, B is equal to C. Then I can say that 2.5 is equal to 5/2. A is equal to C. So if 2.5 is the same thing as 2.5, and 2.5 is the same thing as saying 5/2, then I can sort of almost think about it as canceling these guys out, right? And what's left over? These two guys. Then I can say that 2.5 is equal to 5/2. Substitution property of equality, and that says that if A is equal to B, then I can replace B, I can replace A with B, or I can replace B with A. They're interchangeable. So if I have A is equal to B, and I have some number, the book says A plus 9 equals 15. Since A and B are the same thing, I can substitute B for A, and I can say B plus 9 equals 15 as well, because they're the same thing. And what did I do? I substituted A with B. Other properties of equality, we have the addition property of equality. And the addition property of equality says that if I add something to the same side, it will be the same. So if A is equal to B, then I can say that A plus C is equal to B plus C. If A is equal to B, then I can say that A plus C is equal to B plus C. So if I have, let's say 10 is equal to 10. 10 is equal to 10. For the sake of argument, if I was to add something to it on one side, let's say I add 4, I have to add it to the other side, because if I have 10 plus 4 here, I would get 14. If I didn't add anything to the other side and I would just drop that 10, you can see that 10 does not equal 14. So for the addition property of equality to work, I have to add the same amount to both sides. By adding the same amount to both sides, then I get 14 is equal to 14, and then I can say that the equal sign remains true. So what I do on one side, I always do to the other. The addition property of equality says if I add one thing to one side, I also have to add it to the other. We also have the subtraction property of equality, which is very similar to the addition property. And that says that if I have A equal to B, then A minus C is equal to B minus C. So if we have the same situation, 10 is equal to 10. If I was to subtract 4, 10 minus 4 would be 6. If I didn't do anything to the other side, it would just be 10. 10 doesn't equal 6. So in order for this to work, I have to subtract the same amount from both sides. Subtract 4 from both sides, and I get 6 equals to 6. Then we have the multiplication property of equality. Hope you guys are seeing a theme with this. Multiplication property of equality, which says that if I have A is equal to B, then A times C is equal to B times C. So if I have, again, 10 is equal to 10, if I multiply it by 4 on the left-hand side, I have to multiply it by 4 on the right-hand side. This turns into 40. The other side turns into 40, and I have 40 is equal to 40. Lastly, we have the division property of equality, And the division property of equality says if A is equal to B, then A divided by C is equal to B divided by C, provided the fact that C does not equal 0. Z can't equal 0 because we can't divide by 0 because it's undefined. So if we have, again, our 10 is equal to 10. And let's further suppose I divide it by 2 over here. That gives me 5. What I do on one side I have to do to the other. So I also have to divide that 10 divided by 2. That also gives me 5. What I do on one side I do to the other. And since 2 doesn't equal 0, it works. When we solve for an equation, a one-step equation, the book gives me a question of 12b equals 18. This is a one-step equation, so I have to ask myself the question, what's happening to b? Right now, b is being multiplied by 12. So in order for me to get rid of the 12 or to solve for the variable, or to find a solution, I need to have b by itself. I need to have b alone. Nothing in front of b. Nothing multiplying b, dividing by b, subtracting by b, adding by b. And it has to equal some solution, right? B has to equal something. Well, right now b is not by itself. Right now b is being multiplied by 12. In order to get rid of that, I'm going to have to do something. The book calls it the inverse operation. I call it the opposite operation. If you want to call it inverse, be my guess. Okay, so what is an operation? Remember, we said an operation, if that's how you spell it. Oh, there's one P. Operation is fourfold, right? It's the mathematical operation. So it's either adding, subtracting, multiplying, and dividing. So right now, B is being multiplied by 12. The opposite of multiplying is dividing. The opposite of adding is subtracting, and vice versa. So I'm going to divide by 12. And I'm dividing by 12 because division is the opposite of multiplication. What I do on one side, I do to the other. 12 divided by 12, they cancel out, and that gives me b by itself. That's what I want. I want b by itself. I have 18 twelfths. I can simplify that. Divide it by 2, and I get 9/6, which gives me 3/4. So I can divide it by 6. Divide top and bottom by 6. So I got b is equal to 3 halves. 3 halves. We also have equations that are multi-step, more than one, full of many operations. So the book has 3 times 2x minus 1 minus 2 times 3x plus 4, and it equals 11x. Alright, so we have a whole bunch of x's all over the place. And the way to solve a problem like this is the first thing we have to do is expand everything out. So I'm going to multiply using the distributive property 3 times 2x and 3 times negative 1 to give me 6x minus 3. This 2 and this minus sign is going to multiply the 3x. This 2 and the minus sign is going to multiply the 4. So negative 2 times 3 is negative 6x. How convenient. Negative 2 times 4 is negative 8. I'm getting a funky, no, I'm not getting a funky number. And it's going to equal 11x. I haven't done anything to the other side. I'm going to use the commutative property and rearrange this a little bit. So I'm going to have 6x plus negative 6x. Actually, I can do that, but I'll just leave it as a minus sign. Minus 6x minus 3 minus 8. That equals 11. X. 6x minus 6x is 0, so these guys cancel out. Negative 3 minus 8 is negative 11. So I have negative 11 equals 11x. What's happening to x? X is being multiplied by 11, so I'm going to do the opposite operation, or inverse, which is to divide. And I'm going to divide on both sides the same number that's being multiplied by x. 11 times 11 divided by 11 is 1. 1 times x is x. Negative 11 divided by positive 11 gives me a negative 1. X is negative 1. So we have here for number 3, we have a word problem. And we know how much you guys love word problems. We're told that we have this big old rug, or carpet, flower carpet. It's huge. And, no, how does to vacuum that on a daily basis? That's horrible. And we're told that this carpet has a perimeter of 200 meters. This carpet has a perimeter of 200 meters. Actually, let's go with the got it number 3, and let's say it has a perimeter of 320 meters. Okay? We're also told, by looking at the picture, we have the width and we have the length. We're told that the width is equal to x. We're also told by the picture that the length is equal to 3x. The width is equal to x, the length is equal to 3x. Since this is geometry class, you should know. Oh no, this is not geometry, this is Algebra 2. From geometry class, you should know that the perimeter of a rectangle, which is what the shape of the carpet is 2 times the width plus 2 times the length. And we already told that the perimeter is equal to 320 meters. So we can say that 2 times the width plus 2 times the length is equal to 320 meters. Okay. So we've done a few things here, right? We've done some substitutions. We substituted 320 for perimeter, for the perimeter equation. Now we're going to use the substitution again, and we're going to substitute x for w, and we're going to substitute 3x for L, for the length. And we're going to have 2 times x plus 2 times 3x. And that's going to equal 320 degrees. 2 times x is 2x. 2 times 3x is 6x. Combine like terms, 6 plus 2 is 8, so 6x plus 2x is 8x. We have 8x equals 320. What's happening to x? X is being multiplied by 8, so I do the opposite operation, which is to divide. And I get that x is equal to 32 divided by 8 is 4. X equals 40. But that's not what we want. We want the length and the width. So now that we know that x is equal to 40, we know that the width is equal to x. So w is equal to x, which is 40. We know that the length is equal to 3 times x, which is 3 times 40, which is 120. So the width is 40, the length is 120. Identities and no solutions. So what does an identity mean? When we have an identity, the book says every value for the variable is true. So usually when you have x equals some number, like 2, it's only going to equal that one number 2. When we have an identity, we can have a situation where x equals all numbers. X equals all numbers. That is called an identity. So what does that look like? Here's an example. So they have a situation where x, they ask if the equation is always, sometimes, or never true. Let's look at it. So for 4a, we have 7x plus 6 minus 4x equals 12 plus 3x minus 8. Combine like terms, 7 minus 4x is 3x plus 6. 12 minus 8 is 4. 4 plus 3x. Uh-oh. I can subtract 3x from both sides. And I have this. They both cancel. The 6 drops and the 4 drops. And I have 6 equal to 4. So get this. They're not the same, right? This is definitely not an identity. When you have a situation like this, then it's a no solution or a null set. It doesn't exist. So there's never going to be a situation, so that we would say never true. There's never going to be a situation where we can find an x. It doesn't exist. And these are situations where we have lines that are parallel. So there's no solution. They won't never intersect. There's not a situation where they're both at the same time. For 4b, we have 2x plus 3 times x minus 4 equals 2 times 2x minus 6 plus x. Okay, I'm going to use the distributive property, and this is 2x plus 6x minus 3 times, no, I'm sorry, 2x plus 3x minus 12 is equal to 4x minus 12 plus x. Alright, combine like terms. 5x minus 12 equals 5x minus 12. Add 12 to both sides. I get 5x equals 5x. Subtract 5x from both sides. and I get 0 equals 0. When you get the 0 equals 0, that tells me that it's an identity. So this is an identity. So I write IDT. This is an identity, meaning this is always true. No matter what x I put in here, I could put in 1, 4, 20, 100, a million, 1,000, -5. Whatever x I put in here, both sides will always be true. And that's the situation if we think about the line where the line is right on top of each other. They're the same line. Literal equations. A literal equation is an equation that has 2 or more variables in it. 2 or more variables in the equation. So in the case of this one for 5a, they say k is equal to c plus 273. So this is K is for Kelvin, so this is temperature. C is for Celsius. Kelvin is Celsius plus 273. They want you to solve, or they want you to find what is Celsius in terms of K, meaning they want C by itself. Right now, C is being added by 273. I'm going to do the opposite operation, which is to subtract by 273, which gives me C by itself. This cancels. So this is Kelvin minus 273 equals Celsius. Now C is by itself, so C in terms of K, and that would be my equation. Okay. Alright, so that is this section 1-4, solving equations. I hope you have a great rest of your day.